Hello, this is Mrs. Mackey, and today we're going to learn to identify properties. Actually, in this video, we are not going to identify as much as learn as the definitions of them. And then in class, we'll be working on the identifying them, using those definitions. So I gave you a handout to help you organize your notes. We call it a graphic organizer. So we're on our first one, identity property. The identity property says that for every operation, now an operation means adding, subtracting, multiplying, or dividing. Those are things we do to numbers. Okay? So for every operation, there's a number that has no effect. It keeps that number the same thing. So if I'm first going to write these in number form. And if you have room, you can add the numbers later. But what I really want you to write in the boxes are the algebra ones. And I'll write those in the boxes. So underneath, let's start with 3 plus some number equals 3. Okay, so I start out with 3, I add something to it, it stays a 3. So what number can I add to 3 that keeps it a 3? That's right, 0. Well, it works that way with algebra too. So if I have a variable and I add 0 to it, it's going to stay that same variable. The variable has not changed. Okay. So if you have room, you can add this in there also. Okay. Moving on to multiplication. There is a number that I can multiply by, and it's going to keep the number the same. So what number can I multiply 3 by to keep it 3? That's right, a 1. Okay. Well, it works that way with variables again. So if I have my variable and I multiply it by 1, well, that variable hasn't changed. Because these are dealing with numbers that stay the same, they don't change, we call it an identity. Because it's like how you do not change over time. Your identity is always your identity. And we talk about, people stealing identities, but that doesn't change who you really are. Okay. All right. Moving on to inverse. Inverse has to do, and notice I highlighted the word reverse. Okay. And I did forget to mention up at the top, there's the definition, and what I've highlighted are the missing words. Okay, so for every operation, anything that you add, subtract, multiply, or divide, there's an operation that reverses it. So it undoes it. But I think of inverse and reverse. So, addition, what's the opposite of adding? Subtracting. Or add the opposite. Okay, what's the opposite of subtracting? Adding. The opposite or inverse of multiplying is dividing. The inverse of dividing is multiplying. Now, squaring, you might not know this one, but squaring is like, well, let's go back and use a number. 3 squared equals 9. Well, if I were going to reverse it, I would take a square root. What number times itself equals 3? So the opposite of square is a square root. Moving on. Okay, commutative. Commutative is, if you think about commuting, your parents, maybe they commute, or maybe you know a friend, or friends' parents commute, and that means they travel. They swap where they were. They were up here in the Antelope Valley, and they commute down to the San Fernando Valley, or I don't know, maybe even all the way down to Orange County. But they're swapping order. They're swapping their place. Well, in commutative property, numbers or variables can swap places when we add. Think about it. If I have 2 plus 3, well, what does 2 plus 3 equal? That's right, it equals 5. Well, doesn't 3 plus 2 equal 5 also? Yes. So in addition, we can do it, and it looks like this. A plus, that looks like a variable. A plus B equals is the same thing as B plus A. and you can write it down here in numbers. Okay? Let's look at multiplication. I'm purposely skipping subtraction for a minute. Okay. In multiplication, I can go 3 times 4 equals 12, but 4 times 3 also equals 12. So it is commutative. I can swap the order out when I'm multiplying, and that looks like in a variable, a times b equals b times a. And I can write it here, 3 times 4 equals 4 times 3. Okay, so I'm going to get these out of the way so I can do the others. For subtraction, let's see if it works. 5 take away 3 equals 2. 3 take away 5. Uh-oh, that does not equal 2. So subtraction? No. We cannot do it for subtraction. Works out the same way for division. Okay, so let's go. 12 divided by 4 equals 3. But 4 divided by 12 equals 1/3. Uh-oh, it doesn't work for division either. It only works for subtraction. I'm sorry, it only works for addition and multiplication. Okay, we're halfway done. All right, associative. We can move parentheses around. It's not going to work again on subtraction or on division. Okay, but let's go. 2 plus 3 plus 4. And put my parentheses in. Okay, 2 plus 3 is 5, plus 4 is 9. Okay, well, let's see how this works. So I'm going to move those parentheses to here. And that's still a plus sign. So 2 plus 3 plus 4 is 7, which gives me 9. Here's how it looks. A plus B plus C equals A plus B. Oh, I really don't like this pen. A plus B plus C. Okay. Works on multiplication too. I can go A times B times C equals A times B times C. I'm having a hard time fitting this in, you might too. So it's okay, remember, if you don't have places for the words or the numbers, but just hopefully you'll remember them as we're talking about the problems. Okay, distributive property. We have done distributive property before. Distributive property gets rid of parentheses. You've done a lot of these with numbers. Now we're going to look at it on how it looks with letters. So, they write it like this, and it equals A times B is AB. When we don't know the variable numbers, we just mush them together, showing multiplication. And then A times C, it's still adding AC. One more. Equality. We've been using the equality property when we solve 1- and 2-step equations, when we move things from one side to the other, because what we do to one side, we must do to the other. And the equality properties are what let us do that. So I can add, multiply, subtract, and divide the same number on both sides. So if I have 3 plus, let me back this up. Oh, no! Okay, so I'm going to do it with numbers down here first. So I have 3 plus 2 equals 5. Okay, well, what is 3 plus 2? 5. So I've got equal here, right? Well, let's go back. Let's say I want to add 4 to both sides. So I add 4 here, and I add 4 here. Well, all of these numbers still equal. 4 plus 3 is 7, plus 2 gives me 9, and 5 plus 4 equals 9. Okay? That's true with my multiplication, subtraction, and division. There's really not, there's a long word definition. I'm not going to write the definitions, but we must do the same thing. And we'll be using these a lot, but definition, I can't think of a good way to put it right now. So we'll probably add that later or just leave it blank and use it. Here's our summary. Properties are tools we use to simplify or solve both arithmetic and algebraic problems. When we're doing the arithmetic, arithmetic is only numbers, okay? When we're doing arithmetic, it really has to do with mental math. So we would do these in mental math or algebraic problems. And sometimes my pen is really wonky. TTFN.